Hey yo, what's up guys? Baby Bear 4812 coming at you one more time. We're here doing everybody's favorite dynamic programming problem, best time to buy and sell stock, part 4 of the series problem 188. And when I say favorite, I mean probably everyone's least favorite. I really think this one's tough. All right, so I think we've been on a bit of a streak recently with tough problems, and we're going to keep it going. If you're not familiar with the rest of this, couple things. If you're not familiar with the rest of the best time to buy and sell stock series, go do the rest of them first before you come to this. Second of all, this like cat's out of the bag already. This will be a dynamic programming problem. And if you're not comfortable with dynamic programming yet, if you haven't done many problems or none at all, I'd strongly urge you to go try some easier ones first because this is a bit of a trickier one to dive head first into. I've done other videos on DP. I think the latest one that I liked at least would have been the longest increasing subsequence. That one kind of does a better job at building up the fundamental building blocks of DP. And finally, the solution we're going to run through today is a perfectly valid DP. Your interviewers are going to love it, I promise. Recently, though, it seems like Leetcode added a whole bunch of extra tests onto it. And so this one just hits a time limit exceeded, partially might also because I'm running in Python, which is a relatively slower language. So I'm not going to run it at the end because it will run into a TLE. I'm not sure why. It actually aligns with the solution that Leetcode provides as well. For what it's worth, I'm throwing that caveat out there. So if you already know how to solve it, but you're getting with DP and you're getting a time limit exceeded, I can't really help you here all too much, but I promise you take this to an interview, you'll be golden with the solution. So I wanted to record the video anyways, but again, I did want to give like a fair heads up before we dive into on what to expect. So now with all those disclaimers out of the way, we're given an integer array called prices, where prices of I is the price of a given stock on the ith day. We need to design an algorithm to find the maximum profit. We can complete at most k transactions. So we're given this prices array, we're given k transactions. Notice that you may not engage in multiple transactions simultaneously. So we must sell a stock before we buy it again. That makes things a tiny bit easier. As a quick example, the prices are 2, 4, and 1, and I can make at most 2 transactions. If I buy on day 1, where the price is 2, and I sell on day 2, the price is 4, so I get a profit of 4 minus 2. So I buy at 2, I sell at 4, I get a profit of 2. I don't need to use the second transaction. I can, but I don't necessarily need to. In this case, this one's a bit longer, and we'll walk through this one in more depth in the whiteboarding. We have 2 transactions, and the best case scenario would be to buy on day 2 and sell on day 3. So we make a profit of 4 here. And then we buy on day 5 at 0, and we sell on day 6 at a price of 3. So we get a profit of 3 there. 3 plus 4 gives us 7, and that's how we've profited 7. Now we're, in terms of constraints, we can have no prices and no k, so that's fine. The only thing this tells us is we're going to need to do some error checking. So maybe even before I forget, I'll throw that in. So we'll see if not prices or not k, we're going to return 0. And then we'll do the rest of the code afterwards, of course. But that's really all that we're gaining from these constraints. Again, super high submission to accepted, low accepted to submissions ratio, which usually is a good sign that it's a tough problem. So like I promised, we're going to look at this example a bit deeper. These are the prices that we're given. The reason, again, high level, I'm not going to dive into the details of how we go about a DP in this video specifically, but dynamic programming solutions come about when we've got a problem that's got A, overlapping subproblems, and B, it's got an optimal substructure, meaning to solve the bigger problem, the solving smaller problems sometimes overlaps. Like there are chances, if I was to do just kind of a straight up top-down recursive solution, I would be solving certain problems multiple times over. And then the optimal substructure tells us that if I'm able to actually solve this problem for smaller problems, then kind of putting that solution together by extension gives me a solution to the bigger problem. And in this case, I can kind of invite you guys to think about why that's the case in this problem. Again, I'm not going to dive into it just because I do want to focus on the logic of this problem in specific and not DP in general. Now, how do we even begin to think about this? Before I dive into the code and building out a DP table and all that stuff, I wanted to take a moment to try to think about this logically. And I will be glancing over, I have my kind of my notes here that I jotted down on how to solve this problem. And I hope that it'll be cohesive. But I have some amount of transactions left and I'm at some day in this time period. What do I actually do? What's the decision that I'm making on any given day? If I can start by defining that just logically, the rest of the problem will unfold a lot easier. On any given day, I would make the following argument. I would say that I can do one of two things. I can either I can do nothing. One of the decisions I can make at some given day, so I'm sitting right here and I check the price of the stock and I say, okay, cool, noted, like roger that, I'm gonna do nothing about it. And so all the money that I've made so far will be like, that's there, it's fixed, it's there to stay, it's not going anywhere. I'm not gonna execute a transaction today, I'm not gonna buy or sell or do anything like that. So if that's the case, that's kind of our easier scenario. We'll say, okay, well, whatever money I've made so far, let's run with that, we'll keep it, and we're not gonna bother doing anything. I think that's pretty self-explanatory. The second scenario is going to be where we're going to execute a transaction. So in this case, we're going to decide to execute a transaction. And I'll put in brackets here, namely that this means I have a stock that I purchased at some point a priori, kind of beforehand. And so we're going to sell and we're going to make some potential amount of profit on this, all right? So these are really the only two actions that I can take. From here, understanding this, I think that this will help us break down kind of the logic. It'll be a bit easier to put the logic together because I'm really just saying I'm only doing one of these two things. Now, it'll be a bit trickier to define what happens kind of systematically in our table if one of these two things happens, but nonetheless, this is where I want our starting point. I want to anchor us in this line of thinking. And what I'm going to do is I'm going to move my big head over here and think about the following. We've got our prices here. So this is this was an array. I've broken it out here because I want to take a tabular approach to this problem where we're going to say, at any point along the way, for me to figure out what my profit is here at a certain amount of transactions, I would have had to know what did I have up to that point. So that kind of goes, that kind of goes with this point here. If I do nothing, the best I could have done was whatever I've done already. So I kind of want to know what I've done beforehand before I reach this day. Similarly, we said that we can have up to K transactions. So in this case, K was 2. So I kind of 2. K was 2. Then hypothetically, I could execute 0 transactions. Maybe if this was all decreasing, maybe if I had my prices were 5, 4, 3, 2, 1, I would never want to execute the prices going down. And again, we're only doing buying here. We're not like we can only take a long position. We can't short it. For those of you finance experts out there who are thinking of shorting that stock. And I'm gonna write PRX for transaction. So at any point along the way, we can have at 0 transaction we can have a certain amount of profit. By day 0 we can have profits. By day 2 we can have a different set of profits. By day 3 we can have another one, and so on and so forth. And like with a lot of DP problems, I'm gonna think about how to actually fill this grid out. And so at any given point, let's say that I'm gonna call this table T, and I'm gonna do the following. I'm gonna say that my number of transactions is T, lowercase t, that's my row. And then my prices, I'm just going to call them, or sorry, they're not prices, I'll refer to them as the day. So I'll kind of say at some given day in some transaction, we will, if my transaction is 1 and my day is 3, it'll be 0, 1, 2, 3, and we'd be referring to this square right over here, all right? So if these are the only two decisions that we need to make, then at any given point, I need to say that, I need to decide what it is that my relationship is here for any given value in this cell. So for some transaction T on some day D, I got the feeling I'm not going to have enough space here. So why don't I do this? I'm going to move this down a bit, and I'll write this underneath. Start a bit more to the left. in my table, for some transaction T and for some day D, either one of two things can happen. And for both of these, by the way, how am I going to make my decision? I'm going to make my decision, like, assuming a perfectly rational consumer, by saying whichever one of these leaves me better off. So whichever one of these is going to maximize my wealth. If I do nothing, if doing nothing is better than executing, I'm going to do nothing. If executing a sale is going to be better than doing nothing, I'm going to execute a sale, all right? So in order to kind of write that out, I'm going to write this maximum relationship, and in case we're doing nothing, okay? If I'm doing nothing, I'm going to want to take the same number of transactions that I've had. So imagine I'm sitting here today. So today's what? Today's Friday. If I do nothing, the most money I could have had on Friday is the same amount of money that I had this week on Thursday, which is yesterday, which is the same amount of transactions, but yesterday. And that's it. If I do nothing, it's really easy. Just say I take yesterday's profit and we're good. All right? That's all we're doing. Now, in case we decide to execute a sale, a few things are going to happen. All right? So now it becomes a slightly trickier. What we can do is think about the following. I'm going to take, so imagine this. The amount of money that I'm going to make today for making the sale is going to be prices of D. So this is my money coming in. Okay, so this is money in. At some point I bought the stock, and we'll get to that, but today I'm going to sell it. And if it's selling for 20 bucks today, I'm going to get 20 bucks of revenue. Cool. What about, so what else do we, what else do we take into account when we're making this actual decision? Just because I bought it today, that means at some point I would have had to have purchased it. So I'm going to say that the profit I made on this was price of D minus prices of I'll just call it X. So X is some day in the past, any day before D, okay? Any day before D. So I'll say kind of X is less than D. And of course it has to be greater than 0. So we bought it on some positive day. So this is the actual amount that I made on this transaction, plus all the money that I would have had so far. So this is money out. So I'll say this is, this is when we sell. This is what we bought it for. And before we decided to buy it, we already potentially had some amount of money that we've made. And that amount, and I think that calculating this part is somewhat like tricky. This is what gets people. But before this amount, we would have had some amount of transactions. So I'm going to write this one out and then I'll explain it. We had some amount of transactions minus 1 at a certain day X. So this right here is what I made before. So what I made before buying. So I'm going to before buying. Okay. So let's try to dissect this. This is the amount of money I make today from selling the stock. At some point, I would have had to purchase this stock for some sort of price X. So the prices at a previous day, a day prior to today, I would have had to have purchased this thing. Before I purchased it, on that day, which is before today, I would have had to have considered all the money that I'd made so far with one transaction less. I've essentially made one transaction of it within my transactions T. What have I done up to this point before I made this transaction? So before I purchased it. This stock we would have had to purchase before we sold it. And since we can't engage in multiple transactions at one time, if we bought it on some day X, between X and D, we couldn't have done anything else apart from just stood still. If I bought this stock on Tuesday, so today's Friday, I have 2 transactions, hypothetically. I've already made one in the past, let's say. I bought this on Tuesday. On Tuesday, I spent a certain amount of money. Today is Friday, right? See Friday up here. Today's Friday. I sold it on Friday. Between Tuesday and Friday, I was sitting here just trying to look pretty. I haven't done anything because I'm only allowed to do one transaction at a time. This is the net amount that I've made. But before Tuesday, there were potentially other transactions that I made at Tuesday or before. This right here, kind of this part over here, is going to represent all the maximum money I could have made so far. But even simpler, I'd argue. Like I said, this is me sitting pretty between Tuesday and Friday, and I've knocked out my second transaction. Before that, I only had one transaction that I'd done, and that transaction happened on or before Tuesday. Maybe there was another stock that I sold on Tuesday, and then I bought this one on Tuesday, right? The one that I just sold today. But that's the key to understanding here what these timelines look like. Money I made today, money I made on Friday, money I paid for the stock on Tuesday, and everything that I've done. This kind of encompasses everything I've done in my previous transactions at and before Tuesday. So what we're going to do, the way we're going to think about how to solve this problem is going to be to say, this actually represents, if this is the money that I made today, right? This is the money I made today. This right over here is what I'm going to call max before today. So I'm going to call this maximum before today. Today, I made this amount of money. Before today, I would have had to have completed some transaction where I paid out for this stock, plus whatever money I made before that day. Again, I'm running with this Tuesday, Friday thing. I paid money on Tuesday. This is all the money I've made up to Tuesday, and then this is what I made on Friday. This is my actual transaction. Sorry, this is my actual transaction right here, the net value of this transaction. This is everything I've done before I was able to engage in this transaction. So the reason then why this dynamic programming thing works out and where we would have these double overlapping calculations is in determining this part over here and what this x is, okay? If I didn't have some smart way to keep track of my maximum before today at every step along the way, well then every time I'm evaluating this problem, I'd have to go from the beginning of the week. So I'd have to say, today's Friday, what was the price on Monday? So what would the value of all this have been on Monday? What would the value of all this have been on Tuesday? What would the value of all this have been on Wednesday? Then on Thursday, then on Friday. So on Monday, I'd have to do that. Then on Tuesday, I'd have to do it for Monday and Tuesday. On Wednesday, I'd have to do it for Monday, Tuesday, and Wednesday. On Thursday, I'd have to do it for Monday, Tuesday, Wednesday, Thursday, and see how we're overlapping these days. We're recalculating them. That's why the piece of code that we're going to put in is we're essentially going to be saying at every day along the way, I'm going to keep track of what my max before today could have been, right? And that's essentially going to be with this logic over here, so that when I get to Friday, I've already calculated like the Monday to Thursday, if you will. I know that sounds a bit vague, but that's going to be the general logic of how we're going to build this thing out. So I'm really trying to find I'm just going to keep moving my head around here while we find something. This is the bulk, and I hope this kind of brings a bit of understanding as to how we're actually going to make this happen. What I think I'm going to do now is I want to jump into the code, but I know we haven't ran through a proper example yet. So what I might do is I might briefly run through an example right now. If you think you're confident with this, you can skip ahead to the part where we just get into the code. But just for sake of completeness, I will also quickly walk through this example by filling in this table right over here. All right, so before we jump straight into filling in this table, let's make our this relationship that we had down here. I want to clean it up just a bit, and what I want to make clear is this: so this relationship I think makes sense. So I don't know if there's a good way for me to kind of grab this and shrink it a bit. But what I would like to do is let me see if I can grab this. Why not? No. Okay, I'm out of luck there. That's fine. Let's do this. So I'll rewrite it up here. And so we're saying that at any given point, we wanted to define two things. So first we said we're gonna have the max between either doing nothing, which was t with the transaction t and d minus 1, or the maximum so far. So the max so far, or max before today, really we called it, was equal to the following. So we said it's going to be max before today. I'll just say max BT, max before today. That's this part, plus today's price. Plus today's price, which is prices of D. The thing is though, we haven't, like I want to make clear what this maximum before today looks like. So this is going to give us at any point, or my computer is also, the max of these two will give us any given entry here. The max before today is equal to the following. It's going to equal the max of, it's almost like a nested calculation. Well, the max before today already, so if we were to do nothing, yesterday's trend, how do I put this? Everything we could have done before today, which would have been dp of t minus 1, d minus 1. So yesterday, d minus 1 represents yesterday, and t represents one less transaction than we had, minus prices of d minus 1. And the reason we're doing prices of d minus 1 is because think about d minus 1 as this price is x. Someday that happened in the past, okay? This x right here, this actually, so this essentially right over here, that's this calculation. That's this calculation right here. X here I'm going to represent as d minus 1, meaning that for every day that I'm checking, I'm going to check what the previous day's price was and what the best I could have done with one fewer transaction. So had I made a purchase yesterday, and at that point I would have had one fewer transaction completed. So this x, instead of being a calculation from 0 until today, d, as I'm taking every step along the way, I'm going to check what yesterday's price was and take that into account when I'm solving for this table. To begin filling this thing out, we're kind of, the first trivial thing we can do is to understand that at 0 transactions we can't make any profit. This is always going to be 0. And you know what, maybe I'm going to block this off just to make it clear, or as clear as possible. And same thing here, if I only have 1 day of transactions, it's not going to happen, all right? Now, how do I actually begin to fill this table out? After we filled the zeros in, so I'm going to try to walk through this pretty quickly because it's a bit of an involved algorithm. It'll take a while to kind of to fill this all in manually. But we ask ourselves now in this position here, what's the best that we can do? The best that we can do is the maximum between what we did yesterday with today's transaction, so that'll be a 0. So one of our options is 0. And the other is the maximum before today plus today's prices. So today's prices are 2. What's the maximum we could have done before today? Maximum before today, originally I'm going to instantiate it with 0 and with negative infinity. So maximum between negative infinity or before yesterday, so this transaction over here, minus yesterday's price, so 3. So if I bought at 3, this means I bought at 3. I had 0, I bought at 3, so I'm down to negative 3. This would give me negative 3. Plus prices of D, which is 2, would get me to negative 1. The max between 0 and negative 1 is going to be 0. Logically, kind of looking at what's happening here, would I want to buy at 3 and sell at 2? No, I would not. I'd rather do 0. Now, at the next step, we're going to ask ourselves the following. We're going to do a similar step, and we're going to say, what's the maximum what I did right over here yesterday, which is 0, right? That was the number we had here. Sorry, 0. And the maximum before today, which again was still at 0. It was still at negative infinity. But if we bought at yesterday's price right over here, if we bought at yesterday's price and we sold at today's price, which is 6, that would be good. We'd make a profit. So we'd have 4. 4 would be our maximum value here. If we continue this pattern, and you can kind of rinse and repeat, and I think it might be a good idea to sit down and try to walk through this by hand yourself, just to see how it would work out. You'd realize that we'd keep filling out these scores here. I think this is a good example to help us get to this logic, but the table itself will be a bit boring. Same thing here. No matter how many transactions we have, this 2 and this 3, we're not gonna make any magic happen here. By the same token of logic, if we were to kind of, by repeating By repeating this logic, you're going to see that the exact same outcome occurs here, and we're going to end up getting a 4. Again, I know I'm kind of speeding through this, but I don't want this video to go on for too long, and I think that this intuition was a bit more important than the example. I think. Let me know in the comments down below if you disagree. I can remake this if this isn't clear enough. By continuing with the same algorithm, we're gonna keep getting these 4s here, and then eventually our final element is going to be a 7. The reason it'll be a 7 here is because when we get to this point, when we're trying to calculate it, we're going to see that the maximum at this point will be the max between 4, that's this number here, so this would be a 4, and the max before today plus prices of D. Max before today would have been a 4, rather, DP of this one right over here would have been a 4. No, sorry, max before today would have been a 4, yes. So this whole thing would evaluate to 4. Plus prices of D, which is 3, we would add a 3, so it would be plus 3, and we'd get 7. Basically telling us that we would have to purchase at 0 and sell at 3. And so if you were to walk through this, this is how your table would end up looking following this algorithm. Again, I know I kind of sped through that a bit quickly. The focus of this video for me more so was to actually give the walkthrough here of how we conceptually understand how to build this thing out. If you have any questions on it, if you don't like the format, do let me know. Like I said, if it's just more confusing than it needs to be, then I'm happy to redo parts of this and to try to give a bit of a better explanation. For the actual code part now, the code's not going to be very involved, believe it or not. So we actually I've got some notes here on the code as well that I'm gonna follow because there's a pretty succinct way to do it. And the way that I wanted to do it was by starting by creating this actual table. So it's going to be a nested array, right? We have this 2-dimensional table, and we know that for the number of transactions, that's going to be our rows. We've got k total transactions, but we want k plus 1 rows, right? So we had 2 transactions here, but we went from 0 to 2 because each of these is a possible number of transactions we can execute. So I'm going to have this for the range up to and including k. So we want to have 0, 1, and 2. Whereas by default, I'm going to fill in the whole table with zeros in range and the length of prices. Or rather, I think I could probably just do this as well. That's for the total number of items and prices. We're gonna fill a 0 across every column, and we're gonna have k plus 1 rows. Now to actually start filling this thing in, we're going to have some sort of nested for loop. So we're gonna have for transactions t for every row. In the length of, in the range of 1, and then we're going to want the length of dp, which will be k plus 1, and we're going to start at the 1 because by default we're going to leave, like I said, all these are going to be zeros. It's only the rest of this table that we're going to be filling out manually with our algorithm. And we're going to have for d for some day in the range also of 1 to the, I guess this would be length of, let me think. This many transactions, so we'll just do until the length of prices. I think that makes sense. Now, let's talk about this. There are 2 things we want to calculate. One is going to be the maximum before today, and we're going to set that equal to something. And then once we have that, we're going to set our DP table at TD equal to another calculation. And once we actually figure all this out, we're just going to return the last item that we had in the table, kind of like how we did here. This 7 would be our result. So how do we figure both of these out? Well, let's do the second one first, where we talked about the maximum over here. So we said we'd have it would be the maximum between yesterday's profit at today's transaction. So dp of t d minus 1, and rather this is all going to go in a maximum. And the second part is today's profit, or today's revenue, excuse me, minus the max before today. So today's revenue, which is prices of D, plus max before today. Okay, so what is max before today? Well, max before today we said is going to equal the maximum of itself and this business over here that we called X. So everything that happened before today, namely from yesterday and 1 less transaction. So it's going to be the maximum of max before today and the yesterday's price with one less transaction, because we're almost simulating here. What if I was to have bought in the stock yesterday? Minus prices of D minus 1. The only thing that we haven't done here is actually said, you know, let's instantiate this max before today. And this, you can almost think about this on a weekly basis. We're going to be resetting this every week. So I'm going to start by saying max before today is equal to just the negative possible value we can have, which in Python is negative infinity. So we can, whatever we do after will always be greater than that. And let me see here. Again, when we jump into this for the week, we'll kind of ask ourselves, what's the best that I could have done? And I say week rather, and I'm picturing these rows as weeks. So really, it's the number of transactions. What's the maximum I could have done before today? And again, we're going to compare that to if we had bought yesterday. So this is where we lost. We're paying out that bought yesterday, but we're adding on all the profit that we could have had so far. And I know the code here was relatively quick, and I'm just going to run and make sure I didn't make a mistake, but I did. And let me try to troubleshoot and see what did I do here that's not correct. Oh, there we go. Yeah, so sorry, but I forgot to reference the actual table. Like I said, I gave that caveat at the beginning. This one, it'll run, it'll hit that, you know, time limit exceeded. Like, oh, it worked this time. That's really bizarre because I've submitted pretty much this identical piece of code before, and it's like it's completely bugged out multiple times. Never mind, I'm gonna have to like slap a caveat over that. But yeah, so this is the solution. It does submit, and yeah, so I hope this video made sense. I think this is this is definitely one of the harder problems to understand in terms of dynamic programming. Probably also the hardest one to make a video on. It took me a lot of preparation. I think there could have been maybe a couple points that could have been a bit clearer, but that's for you guys to decide and to let me know in the comments if there's something that you still want me to clarify here. Otherwise, thank you for watching. Like, comment, share, subscribe, all that good stuff, and I'll see you in the next video. Peace.